Okay. So again, that's what the solution set there is. There you're just including the number b. On the end, the next two greater than, there you're looking at the numbers that are greater than b. Okay. Okay, so here, these are all numbers between a and b. Okay, that's just, again, by definition. These are all the numbers between a and b, right? That's what the solution set for this would be. All x greater than a and less than b. Well, that's exactly what this interval is, right? That's exactly what this interval is here. And, so on and so forth. Again, when you're including a number, right, when you don't have strict inequality, but you have inequality, that's where the square bracket comes into play. Now, just like with equations, okay, what we can also have are inequalities that have no solutions. That can also happen. We can also have inequalities that have no solutions. And how do we denote, what can we use to denote that? We have this thing called the empty set. That's just, again, the set that's empty, a set with nothing in it. It's actually denoted by either of these notations. I'm not sure if there's other notation people use, but I know these two notations are used, the empty set. I don't remember if I went through this when I went over what a linear set is, but I'm going through it now. Excuse me, not linear set, what am I saying? What an equation is, the solution set of an equation. Okay, sorry, I misspoke. Okay, so that's what these solution sets are. But now you should be wondering, okay, so how do we actually solve these inequalities? Well, you're basically going to proceed just like you solve equations. You're going to proceed in the same way, just like you solve an equation. We can do things to an inequality to make it easier to solve. Just like with equations, right? There are certain manipulations you're allowed to do. I mean, you can't do anything you want, but there are certain manipulations you're allowed to use. It all boils down to not changing the solution set. Okay? For instance, you can simplify either side of this inequality. You can do that. You can simplify either side of the inequality. Either side, meaning the left, the right, or both sides. You can add or subtract the same thing to both sides. You can do that. I know in the book, I think they go into that domain stuff, but that's really not going to be an issue in this class. You can also multiply or divide both sides of the inequality, not equation. I don't know why I didn't take that out, but take it out now. But again, when you multiply or divide by something negative, that's when you have to be extra careful. Namely, when you multiply or divide by something negative, you have to turn the inequality around. That's what you have to do. You have to turn the inequality around. When you multiply or divide by something negative, I'm going to show you why right now. So here, okay, let's suppose we start out with this inequality. 1 is less than 2. Right? That's true, right? Okay. But what happens if we multiply both sides by -1? And let's say for some reason we forget to flip the inequality. When I say flip, I mean turn it around. So less than, let me see if I can, well, you'll see what I mean with when we do the examples. If I don't turn this inequality around, what we have is this, which is a false statement. -1 is not less than -2, right? So this inequality has to be turned around. Let me see if I could draw it actually. In other words, here, this should be the inequality. right? You can see that you have to turn the inequality around. Otherwise, it's not true anymore. Here's another one. We have 3 is greater than 2, right? Yeah, that's a true statement. 3 is definitely greater than 2. But now, right, if I multiply both sides by a negative, right? Negative 3 greater than negative 2, that's not true anymore. So that's gone. And so instead, we have to have this one, right? We have to turn the inequality around. So that's what we have to do. Okay. Now, are there any questions about this? Okay. Well, let's do this. Okay, so let's do some examples now. All right. So we're going to solve this inequality. Yeah, okay. I thought I skipped a slide, so I'm glad I was wrong about that. We're going to solve this inequality here. We're also going to graph it. Okay? We're going to graph the solution set, that is. Excuse me. Okay, good. So we have 5x plus 1 less than 7x minus 3. So I wrote it out. Again, just like with equations, okay? Just like with equations, you want to get x all alone on one side, right? You know what? Let me go back. This will make it easier. You essentially want to get one of these inequalities here. So whenever you're solving an inequality, you essentially want to get one of these, at least. Because then you get the solution set easily. That's the goal, right? But, sorry, I skipped ahead accidentally. But again, notice in either case, in the first 4, actually, x is all alone, right, on one side, the left side, but it could be the right side. When we get the compound inequalities, x has to be all alone in the middle. Okay? X has to be all alone in the middle. Okay, good. Okay, so that's what we want. So here we have 5x plus 1, right? That is going to be less than 7x minus 3. Excuse me. Right? We want to get x all alone. So I'm subtracting 1 from both sides. Again, there's more than one way to proceed, but you have to somehow get x all alone. So I'm subtracting 1 from both sides. Okay? We get 5x is less than 7x minus 4. Okay? We get that. Then we subtract 7x from both sides, as you can see. Once we do that, we have minus 2x is less than minus 4. Minus 2x is less than minus 4 we have. Right? Again, let me start again. We subtract 1 from both sides. We get 5x is less than 7x minus 4. Subtract 7x from both sides. We get minus 2x is less than minus 4, as you can see. But so now we have x all alone, but we're not quite done yet, right? We want x, we don't want minus 2x, we want x. So I guess we don't have x all alone yet, but we are close to done though, right? You can see that we just have to divide both sides by minus 2. Minus 2. Dividing both sides by minus 2, what happens? Well, you can see that the minus 2's cancel. We have x is greater than, we divide both sides by minus 2. Notice we flipped the inequality here, right? Let me draw an arrow if I can. Right? Notice what we did. We flipped the inequality symbol, right? Why did we do that? We divided both sides by -2. That's what we did. So we have x greater than 2. That's our solution set. Well, excuse me, that's our inequality we get, and we know the solution set to that. It's the interval from 2 to infinity. You know, it's all numbers greater than 2. That's what we get here.